Hey, what's up guys? I am stripping down some prismatic cell based batteries for use in making a bigger battery for my RSF 650. I got a whole bunch of these. They're Powerizer 37 volt 6.4 amp hour battery packs. I got them from a kind of a technology recycling center. I know somebody on the inside. They call me when they get interesting stuff in, and they had a whole bunch of these batteries come in that are essentially brand new. I mean, they were still in factory wrapping. Took them out of their bag. The ends are still all taped up. Voltage is perfect on them. Powerizer seems to be a pretty good name brand of battery. At least they got a good website. A lot of stuff on there. This particular battery was like 350 bucks on their website, something like that. And I got a whole pile of them. Almost feels like a bit of a waste cutting these things apart. Just, I mean, they're, you know, good quality construction. Obviously quite expensive if you wanted to just go buy them like this. But I put it out among some of the battery building groups, and nobody seemed to be very interested in them. I actually listed them on eBay for a while. Nobody seemed to want them. I don't know why, but what the heck? Since I got them and I didn't really pay. Honestly, I didn't pay anything for them. Yeah, I'm just going to break them down to their individual cells and reorganize it into a battery that is good for my usage. So I thought it'd be kind of fun to show you guys breaking down one of these batteries. You know, these are lithium-ion cells in here. They're what is it, prismatic or pouch cells or whatever the heck you call them. They're a little less, physically robust than, say, like an 18650 cylindrical cell, because those are in a metal case, and these are basically just kind of loose bag cells. But you'll see them here in just a second. So we're going to cut this outer wrapping is some kind of polyolefin. It's like a heavy rubber shrink wrap, like shrink wrap you'd use on your wiring, except this was obviously much bigger gauge, and they have shrunk it onto here, and I'm guessing that's where they got the compression for the pouch cells. It was out of the casing. I'm just going to peel that off. Yeah, starting to see this side of the cell there. They got another layer of shrink wrap on here. I think that's less about compression because it needed to be compressed this way. I think this is just your standard PVC heat shrink on there. We'll go ahead and get that off. And I want to be extra careful. I'm using my knife. I'm cutting up and away from the cells here, because I don't want to accidentally knock a hole in one of these. I've got a metal bin next to me here. If something takes off, I can chuck it in the bin real quick and hopefully get it outside. But these things, you just don't want to puncture them. Be a bad day. Right on. Outer wrapping is off. You see we've got 10 individual pouch cells in here. Got a surprisingly chunky BMS on these things. Pretty heavy main battery cables. Had a charging port hooked up directly to it. I'm not a complete electronics expert or a BMS expert or anything like that, but to my eyes, I mean, this BMS looks pretty darn chunky. I mean, the MOSFETs are real heavy gauge. Leads coming out of there. It's got a real big aluminum heatsink on there. All these traces and bus bar doohickeys are really heavy gauge, heavy soldering. I mean, that's to my eyes, that's pretty good, but what do I know? We're just taking this apart. So first thing we're going to do is get the business end taken care of. And we're getting down to the leads. Get these guys uncovered. And I'm going to desolder the power wires off of the battery here. Any chance I get, I usually try to use a piece of wood to pull all these electronics off when I'm prying down in there, because that's not going to short out. And I ain't going to get burnt by my mega iron here. Okay. BMS is no longer connected to the battery. At least not the main power cables, still got all the balance leads on it. Let's see, what do we want to do next? Let's get this paper off of here. So that being a 36 volt battery, 10 cells at 3.6 volts. They're just 10 cells wired in series. Each tab zigzagged across. I'm going to get these balance wires desoldered and off of here and out of my way. And yeah, we'll do the wires first and then come back and get the tabs last. I think it'll keep it a little easier to work with. I'm using this super heavy duty soldering iron here. Puts out a lot of heat really quick. Since it's such a heavy end on this thing, it retains a lot of heat. The idea being, that much heat energy hitting this thing real quick, it's just going to kind of flash melt the solder without the heat conducting down into the battery too much. Ideally, pouch cells would be held together with, more mechanically, like fasteners through bolts, rivets, something along those lines, because you don't want to add all this heat into these battery cells. But using a real heavy doohickey like this, keep some of the heat out of the cells. And I mean, clearly, the manufacturer soldered everything on, so how bad can it really be? And if they're charging 300 and some odd bucks for these batteries, I think they'd stand by their work. But what do I know? Alright, that BMS is completely disconnected. It's held on to the battery. This is adhesive backed paper. I'm just going to peel the whole thing off. Maybe. Sticky. Boom. So that's a BMS board, and then there's adhesive foam tape holding that to a piece of fiber resin board. which is then foam taped with some pretty stout stuff onto the adhesive paper. And these things are pretty sturdy built. They don't want you getting in here. See any major dents or nicks in these cells anywhere? I don't know the full history of these things, since I did in fact get them from a recycling center, and a couple of them looked pretty beat up. This one seems to be okay. Yeah, I checked voltage, checked capacity, I ran a test on these things, and they were performing just fine according to their specs and everything, so they should be good batteries. Should be good cells too. We are going to now get the series connections unhooked so we got individual cells to work with. And you may end up seeing some sparks out of this, because if these tabs touch, it's going to create a short, and several times doing this I've accidentally made a short with my soldering iron here. You get a few sparks and you go, whoa, don't do that again. So we're electrically disconnected each individual cell. They're no longer touching each other. I'm just going to cut this tape off of here and we'll have our individual cells to work with. This is some kind of, it's a fiberglass reinforced tape. And again, I just want to be super careful. Cut the tape, not the battery, please. And so on and so forth until we have them all apart. So the cells that we have to work with here, see if I can get that focus. 3.7 volts, 6400 milliamp hour 5C discharge, and it should push, what's that math, 30 something amps. Tabs are cut quite short on one side. That's going to be it's going to be a pain to work with later, but we'll get to that. So yeah, on the PowerWiser website, I think this individual cell was like $24. And yeah, I'm just taping off the end, storing them till I do testing and assembly. That's it.